So question 16 is about population growth, and we're given the formula for that growth in that the population of the next year is k times the population of the year before, where k is a positive constant. And we're given the fact that our starting point in year 1 is 8 million, and we're given that the population of this species at the end of year 2 is 6 million. So the population has gone down, so it may be a positive constant, but it's less than 1. So let's work it out. The fact that in year 1 we've got 8 million, and in year 2 we've got 6, I can say that 6, the new population, is k multiplied by 8. So therefore, k is equal to 6 over 8, which is equal to 3 over 4. So we're now after the population at the start of year 3. This was P1, remember? This was P2. So P3 is equal to k multiplied by P2. So therefore P3 is equal to 3/4 multiplied by 6, which is equal to 4.5. And this is in million. And that will be your answer. So let's have a look at part B. So we're told that at the start of year 5, the value of k is increased by 0.3 to a new constant value. And Louise thinks that from the start of year 5, that's when that increase happens, the population of the species would increase year on year. Is she correct? And give a reason. So putting those facts down, up to year 5, k is equal to 0.75. And Louise says that after year 5, we've got a 0.3 increase to k. And we can express that by saying the new k, k dashed, is equal to the old k plus 0.3. Now, k being 0.75, this gives a value for the new k of 1.05. And as I alluded to earlier, if you have a k of greater than 1, your population will go up. So, yes, she is correct. Let's just write that down. As k dashed, our new value of k is 1.05, which is greater than 1, the population will increase. And that's going to be your answer.